Today we're going to look at recursive definitions. So we've already looked a little bit at explicit. Now we're going to talk about recursive definitions. So recursive definitions are kind of a three-part equation. The parts would be your initial value, your recursive rule, like the actual rule itself, and then the last part is the domain. So when you start writing out the recursive definition for a sequence, the very first thing you always want to look at is whether that sequence is geometric or arithmetic. And the way that you can tell is geometric is multiplying and arithmetic is adding. So if we were to look at this first sequence here, it doesn't have anything to do with increasing or decreasing. If you take the last number and you either subtract the one before it or divide by the one before it, that will tell you whether or not, will tell you what your either growth factor or your common difference is. If it's geometric, it's called a growth factor. If it's arithmetic, it's called the common difference. So for this one, you can tell that the distance between these two numbers is not the same as the distance between these two numbers when you're adding or subtracting, and so that means that this one is a geometric sequence. Okay, and geometric sequences use multiplication. So to figure out what it's being multiplied every time, you take the last number and you divide it by the one right before that. So you would take 8 over 40, and that reduces down to 1/5 or 0.2. And so this number right here is our common ratio. And you might hear me call it growth factor, common ratio, growth factor. Those two things mean the exact same thing. So then to write the actual recursive definition, we have to have all three parts to it. So the initial value is just, what does this sequence start at? And we write it like this. And it doesn't matter what you name your function, it doesn't matter what variable you use, as long as you're consistent throughout that definition. So here we're going to say our first value is 200. Okay, number here, number over here. The next part is going to tell us, this is the rule, so this is our initial value. The next part that we're going to give is the rule. So what that says is that for any input, we're going to take the previous output, so this just means previous output, and in this case, because we're multiplying and we have a common ratio, we're going to multiply times that common ratio, so times 1/5, and then the domain tells us what inputs that's good for. So we started with an input of 1, which means that we need our other inputs to be greater than or equal to 2. So that means that we start with 2. That's the first input that has a previous output. So we can't do a previous output for this one because we don't know what the output before it was. With our n being greater than 2, now we can take that previous output and multiply that times 1/5. Then to find this one, take the previous output, multiply times 1/5. To find the next output, take the previous output, multiply times 1/5. So this part is your actual domain. If we look at this next term here, or at the next sequence, you can see that the distance between each one of these numbers is the same. So this one is arithmetic because we're adding the same number every time. And the common difference we take the last one and subtract the one right before it, we get 30 minus 20, which is 10. So the common difference is 10. So again, three parts to the recursive definition. You have the initial value, you have the actual rule itself, and then you have the domain. Okay, so for the initial value, again, we're just gonna say, we'll use a different one this time, we'll use H. The first value in this sequence is 10. For the rule, it's saying we're gonna take the first, we're gonna take any input, we're using H now, H of n minus 1, so this just means take the previous output and then add 10. In this case, we're adding 10 because it's an arithmetic. Arithmetic means add, and we're adding 10 because that's what the common difference is. So here's the initial value. Here's the rule. The domain is always going to be increasing this number by 1. So n is greater than or equal to 2. So if this sequence had started at like 5, the number here would be 6. If this number here had started at 27, this number would be 28. So this number for your domain is always 1 greater than this input value here. All right, and then this is the last one that we're going to look at, and then you can choose whether or not you want to continue with this or whether you feel like you're solid with it. All right, so the last one, you have f of 1 is 100, f of 2 is 20, f of 3 is equal to 4. So really what you're looking at is these y values, these outputs here. This is your function. So again, you can see that the distance between these numbers is not the same, so that tells us that this is a geometric function. And so to find what that growth factor is, you take the last number and you divide it by the previous number. So 4 over 20 reduces down to 1 over 5 or 0.2. So this whole thing right here is our growth factor or common ratio. Either one of those is a correct term. So again, we have 3 parts to that recursive definition. We have the initial value, we have the actual rule itself, and then we have the domain. Okay, so again, we're only using those y values, these that are underlined here, that's our sequence. So let's see, since they're using f's, we'll use f's. F of 1 is equal to 100. That's our initial value, that's where our sequence starts. The rule is that we are going to take, for whatever output we're looking for, we take the previous output, so f of n minus 1, and in this case it's a growth factor, it's geometric, that means that we are multiplying times 1/5, and the domain is that n is greater than or equal to 2.